In January 2003, the world was captivated by a strange and intriguing story that seemed straight out of a science fiction novel. A man named Andrew Carlson was arrested for insider trading. His arrest sent shockwaves through the financial world. Carlson had made a series of incredibly successful stock trades, turning a modest investment of $800 into a staggering $350 million in just 2 weeks. His uncanny ability to predict stock movements raised eyebrows and suspicions. When questioned by authorities, Carlson offered an explanation that was nothing short of unbelievable. He claimed to be a time traveler from the year 2256, sent back in time with knowledge of future events. According to Carlson, he had used his advanced knowledge of future stock prices to amass his fortune. He described a world filled with technological marvels and advancements that seemed like pure fantasy to the present-day investigators. Carlson's story seemed too fantastical to be true. However, investigators were genuinely puzzled by the details he provided. He spoke of future events and technologies with such confidence and precision that it left them questioning the boundaries of reality. Despite their best efforts, they couldn't find any records of Carlson's existence before December 2002. It was as if he had materialized out of nowhere, with no past to trace. The mystery deepened when Carlson vanished without a trace. It was as if he had simply appeared out of thin air, and then disappeared just as mysteriously. To this day, the enigma of Andrew Carlson remains unsolved, leaving many to wonder if he truly was a man from the future, or just an elaborate hoax. The lack of any background information on Carlson only deepened the mystery. Normally, people leave a trail of documents throughout their lives: birth certificates, school records, employment history. But Carlson had none of that. It was as if he had never existed before 2002. The authorities were baffled. Was Carlson telling the truth? Could he really be a visitor from the future? Or was there a more mundane explanation for his sudden appearance and his incredible stock market success? The mystery of Andrew Carlson took another strange turn before his case could go to trial. He simply disappeared from his jail cell. One minute he was there, and the next, he was gone. No one could explain how he had escaped. Carlson's disappearance only fueled the speculation surrounding his story. Some believed that he had truly returned to his own time. Others suspected that he was a clever con man who had staged the whole thing. The idea of time travel has always captured our imaginations. From H.G. Wells's The Time Machine to the Back to the Future movies, we have been fascinated by the possibility of journeying through time. But is it really possible, or is it just a product of our imagination? While the idea of hopping in a time machine and visiting different eras is appealing, the reality of time travel is far more complex. To understand it, we need to delve into the realm of physics, particularly Einstein's revolutionary theories. Section 5. Einstein's universe. Albert Einstein, one of the most brilliant minds in history, revolutionized our understanding of space and time. His theory of special relativity, published in 1905, introduced the concept of time dilation. This theory states that time is not absolute, but is relative to the observer's frame of reference. One of the key takeaways from Einstein's theory is that time slows down as an object approaches the speed of light. This phenomenon, known as time dilation, has been experimentally verified and has profound implications for the possibility of time travel. Section 6. Atomic clocks and jet planes. One of the most compelling pieces of evidence supporting Einstein's theory of time dilation is the Haffel-Keating experiment conducted in 1971. This experiment involved flying atomic clocks around the world on commercial jetliners. The results of the experiment were astonishing. The atomic clocks that had flown around the world showed a slight but measurable time difference compared to the clocks that had remained stationary on the ground. This experiment provided concrete evidence that time is indeed relative to motion. Section 7. The pull of time. Time, an ever-flowing river, is influenced by many factors, one of the most intriguing being gravity. Einstein's theory of general relativity revolutionized our understanding of time and space. He predicted that gravity affects time, a concept that was both groundbreaking and mind-bending. Imagine a heavy object placed on a stretched fabric, causing a dip. This is a simplified way to visualize how gravity warps space-time. The stronger the gravitational field, the more pronounced the warp, and consequently, the slower time passes. This fascinating phenomenon means that time moves slightly slower at sea level, where the gravitational pull is stronger, than it does on a mountaintop, where the pull is weaker. Though the difference is minuscule, it is measurable and significant in the realm of physics. This concept, known as gravitational time dilation, has captured the imagination of many and has been vividly depicted in science fiction movies like Interstellar. These films bring the abstract theory to life, showing its dramatic effects. In Interstellar, for instance, time moves significantly slower for astronauts who venture near a black hole due to its immense gravitational pull. This creates a stark contrast between the time experienced by the astronauts and that on Earth. In a less dramatic but real-world example, Russian cosmonaut Gennady Padalka holds the record for the longest total time spent in space. During his time aboard the International Space Station, he experienced time slightly differently than those on Earth, effectively aging a tiny bit less due to the weaker gravitational field in orbit. These examples illustrate the profound impact gravity has on time, a concept that continues to intrigue scientists and laypeople alike. As we delve deeper into the mysteries of the universe, the pull of time remains a fundamental aspect of our understanding of reality. From the ancient sundials to the precise atomic clocks of today, our quest to measure and understand time has been a journey through the very fabric of the cosmos. The pull of time, influenced by gravity, is a testament to the interconnectedness of the universe. Section 8. A long nap to the future. While traveling to the past poses significant theoretical challenges, traveling to the future seems more attainable, at least theoretically. One proposed method is through cryosleep, or cryogenic preservation. Cryosleep involves preserving a human body at extremely low temperatures, essentially halting the aging process. While still in its early stages of development, cryosleep holds the potential for humans to sleep through centuries and wake up in the future. Section 9. Looking back at yesterday. While the possibility of traveling to the future is intriguing, traveling to the past is where things get really tricky. The allure of revisiting moments long gone, correcting past mistakes, or witnessing historical events firsthand is undeniably fascinating. However, the complexities involved in such a journey are immense. The concept of going back in time raises numerous paradoxes and challenges our understanding of cause and effect. Imagine the intricate web of events that have led to the present moment. Altering even a single thread could unravel the entire tapestry of history. One of the most famous paradoxes is the grandfather paradox. This thought experiment delves deep into the potential consequences of time travel. This paradox asks what would happen if you traveled back in time and killed your own grandfather before your parent was born. The implications are profound and perplexing. Would you cease to exist? If you never existed, how could you have traveled back in time to commit the act in the first place? This creates a loop of contradictions that defies logic. If so, how could you have traveled back in time in the first place? The very act of changing the past could prevent the future from unfolding as it originally did, leading to a cascade of unforeseen consequences. These paradoxes highlight the complexities and potential contradictions of backward time travel. The more we delve into the concept, the more questions arise. How would the laws of physics adapt to such anomalies? Could alternate timelines or parallel universes offer a solution? The mysteries of time travel continue to captivate our imagination, pushing the boundaries of science and philosophy. As we ponder these questions, we are reminded of the delicate balance of our existence and the intricate dance of time. The past, present, and future are intertwined in ways we are only beginning to understand. While the dream of time travel remains a tantalizing possibility, it also serves as a humbling reminder of the complexities of our universe. Section 10. The truth about Carlson. As intriguing as Carlson's story was, it turned out to be just that, a story. The tale of Andrew Carlson, the time-traveling investor, was a hoax, a fictional narrative created by a weekly tabloid. There was no evidence to support his claims, and his disappearance was never explained. While Carlson's story was debunked, it served as a reminder of our fascination with time travel and the mysteries of the universe. The desire to unravel the secrets of time continues to drive scientific exploration and inspire our imaginations. Section 11. Keep exploring the unknown. Though we may not have time machines yet, the universe is full of real mysteries and scientific wonders waiting to be discovered. From the vastness of space to the intricacies of the quantum world, there's no shortage of fascinating phenomena to explore, so keep asking questions, stay curious, and never stop exploring the wonders of the cosmos. You never know what incredible truths lie just beyond the horizon of our current understanding.